Okay, so here we go. The 1, 2, 3, fourth one on 4. So it just says solve. I know it seems a little confusing because of this fraction, but what I would do is I went ahead and distributed 1/2. Because think about this, guys. What's half of 6x?
3x.
Okay, so that's there. What's half of 4?
2.
Now here we go. So it's still a little odd because I have that fraction. I'm going to move this up here for room. So, back here. So I've got 3x minus 2 equals 2/3 x. Now, I've got x's on both sides, so I do need to get those together. I'm going to bring this 3x over, even though that's not really bringing the baby to the mama. I'm kind of breaking my rule here. Now, in order for me to do 2/3 minus 3, I'm going to need to get a common denominator. So 2 over 3 minus 3 over 1. What would be the common denominator? 3. So it's going to be 2 over 3 minus, think about this, 1 times 3 is 3, 3 times 3 is 9. So 2/3 minus 9/3, it's going to be negative 7/3 x. This is weird. This is the life of fractions. Okay, now in this case, my coefficient is a fraction, negative 7/3. Does anybody remember, how do we move that? How do we get this alone if the coefficient is a fraction? One step you can do it with. Times it close by, how about the reciprocal? Because if I multiply by reciprocals, they'll cancel one another out. So now I'm going to multiply this side by negative 3 over 7, and this side by negative 3 over 7. So on the left-hand side, negative 3 times negative 2 is positive 6. It'll be 6 over 7. On the right-hand side, negative 7/3 and negative 3 over 7, that's going to cancel out. So I get x equals 6 over 7. Okay. So that was that fourth one on number 4, or page 4. Any other questions on that page 4? Sydney? Number 3. Okay, so let me look there. Oh, this was tricky. Okay, so it says solve for t. This is one of those literal equations where we're just having to juggle stuff, move things from one side to the other. So one of the things that I did, I noticed, well, this is weird. We have 2 p's. You've got this p and this p. So what I'm going to do is I'm going to take out a greatest common factor. So I'm going to say a equals, I'm going to do a p followed by a set of parentheses. Since they both have a p, I'm like, hey, let's take that out of there. So if you divide, what's p divided by p?
P.
What's 5 divided by 5? 1. And if I divide the other part by p, p over p cancels out, and you're left with RT. Now, the directions of this problem were to get this t by itself, so I'm not quite done. Now I'm going to go ahead and move p out of here. So I'm going to divide by p. So now I'm going to move this up here for room. A over p equals 1 plus RT. Got to get t alone. So what should I move now? The 1 or the r?
You get rid of the 1 first.
The 1 first. So I'm going to do minus 1 on each side. So now I've got a over p minus 1 equals RT. Well, you know what? Let's back this up a little bit. Because you could do this, but then you'd have to divide by, you'd have to divide by R. And then that'd look kind of messy. Y'all see that? So let me, Houston, let's go back. We have a problem. Let's go back for a second. You're jumping out of the spaceship?
Helicopter and airplane. Yeah, I'm
Okay. So let me just do that.
Action.
Okay, guys, so let's take a look. You're going to just copy these notes down for me. That's how we're going to do this. So a relation is a set of ordered pairs. Remember, every ordered pair has to be x, comma, y. Okay, the graph. When they talk about a graph, that's just our regular coordinate plane. So you can kind of just draw a little graph, and it doesn't need to be big. We should all know where the x-axis is. I'm putting a little x there, and we should know where the y-axis is. So I'm just going to put that there. We'll kind of get into that more. Okay, ordered pairs, x, comma, y, and we'll talk more about that in a minute. Okay, mapping diagram. A mapping diagram is where you have your x values in one column and your y values in another column. And what we would do is we would draw little arrows from the corresponding x value to the y value. Again, in the next couple of pages, we're going to do an actual mapping diagram where you can come back and look at that. The main thing about a mapping diagram is it has arrows. Okay, input-output tables, that's literally just a table where you'd have your x values and your y values. So you'd have your ordered pairs all lined up like this, x, y, x, y. In an input and an output table, we don't have any arrows. That's just for that mapping diagram. Does anybody remember what the domain is? Okay, not all at once. Domain. Somebody, anybody, help me. Come on. Wow, good thing we're going over this. That's all the x values. It's also referred to as the input values. It's the first number in the ordered pair. So now that you know domain, well, what's the range? Y. Oh, you're so smart. Yes, it is. Y values, also known as the output values. Okay, last definition is a function. We had a lot of questions where it would be like, hey, is this a function? Does that represent a function? And the easiest way, in my opinion, to figure out, it's going to be a relation. Now, we just talked about a relation. That was the first definition. That just means ordered pairs, a whole bunch of ordered pairs. But it's a relation with no repeating x values. That's how you can tell if you have a function or not. We can't have any repeating x values. You could have a repeating y value. That doesn't matter. It's just no repeating x values. All right, so what we're going to do is we're going to practice a little bit of this sort of thing. And the very first type of question, it's just a graph. We've got some points on there, and it says, is it a function? So first off, I have to just say yes or no. No. Is this a function? No. And right, it is no. An easy way to do this would be to go through, and for each point, I'm going to write out the ordered pairs. So this first point up here is 4, 2. Then I've got 0, 2, 0, negative 1, 4. Oh, this should be negative 4 over here, sorry. And then this last guy down here is 3, negative 3. If I list out all those ordered pairs, one of the things, and I know a lot of you already said, no, it's not a function. You're right, it is not. The reason is, if you look at this, we have two x values that are 0. And part of the definition of a function is you can't have any repeating x values. So the first answer is no, it's not a function. Now the second question is saying list the domain. So we just did the definition. Domain means the X values, but there's a specific way we have to list domain. Does anybody remember? Yeah, least to greatest. So when I go to list this domain, I'm going to go ahead and I'm going to do it least to greatest. So basically, if you have a graph, one of the nice things is just go left to right. That's going to already have it listed least to greatest. But there's one other thing, no repeats. So my domain is going to be -4, 0, 3, 4. I didn't say 0, 0 because I'm not allowed to have any repeats. Let's take a look at the last one on this page. This time, instead of giving me a graph, it just gives me a whole bunch of ordered pairs. And from that, they're saying, hey, what's the domain? Well, domain is going to be all of my X values. You can color code it like this if you want. Don't forget, you have to list this least to greatest. They already have this all listed least to greatest. Are there any repeats there, guys? No. So when I go to list my domain, I'm saying -1, 3, 4, 5, 7. You just separate these numbers with commas. When I go to do the range, that's going to be all my Y values. These also need to be listed in order, least to greatest. So I'm going to say 0, 2, 3, 5. I do have a repeating Y value. There's the number 3 twice. You still will only list that once. Last question. Function or not a function?
No, yes.
Yes. There's no repeating X values. Okay. Moving on. Guess what this thing's called right here?
Circles.
No. Your mapping diagram.
Oh, that's okay.
That's what that is. See the little arrow? Arrows, I should say. So now I'm looking at a mapping diagram. They're just presenting this function or relation, I should say, in a different way. But they're asking the same question. Is that a function?
No, it is
Right,
not.
it is not. Okay, some of you can just look at it and tell. If you can't do that, one of the things you could always do is go in reverse, list the ordered pairs. -3 is getting matched up to 2, but -3 is also... Okay, so -3 is also matched up to 7. And then from there, I can see that -1 is paired with 5 and 0 is paired with 10. We do have a repeating X value, so that's not a function. Okay, taking a look over here, something we had previously learned about was the vertical line test. So if I draw vertical lines through this graph, it never intersects more than once. That means this is a function. Okay, so taking a look at this next one, again using the vertical line test, if I just draw vertical lines through, you can see that it intersects the graph more than one time. If it intersects more than once, then no, it's not a function. Okay, moving to the next one, here we have a table, and we've got input, output, so it's asking me for the range of the function. That's going to be all of the output values, 3, 7, 12, and 18. Okay, coming down here, we're going to go into function notation. So it says for the function f of x equals -2x plus 5. They want me to evaluate that for f of -3. Basically what that means is they want me to plug -3 in where we see these x's. So for f of -3, the way I'm going to write this out is going to be f of -3 equals -2 times -3 plus 5. And now from here, I'm going to simplify that. So -2 times -3 is positive 6. 6 plus 5 is 11. Okay, taking a look at the rest of these, we have some word problems. So it says, imagine you need tickets for an amusement park. Tickets can be bought online for $40 plus a one-time service fee of $3. The first thing that they want me to do is come up with an equation to model the cost of the tickets. So I could say something like f of x, we're going to use our function notation, equals, and it said it's $40 plus a one-time service fee of $3. 40x plus 3. $40 per ticket and a $3 service fee. As we move into the second part, it's saying how much will 4 tickets cost? So now what they're wanting me to evaluate is f of 4, plugging in 4 to see what we'll get. So 40 times 4 is 160, 160 and 3, $163 to buy 4 tickets for that particular amusement park. The last one here is very similar. If your cell phone bill has a monthly fee of $3.50 and your rate is 20 cents per minute, the first part of the question wants me to come up with an equation. We've got to use this function notation. So f of x equals, I'm going to say 0.20x because it's 20 cents per minute, plus $3.50. That's that flat fee of $3.50. For part B, how much will it cost if you use 200 minutes? Now it's basically saying plug in 200. So we're going to do 0.20 times 200. That gives me 40 plus $3.50. So we end up with $43.50. All right, guys, let's take a look here. We have to evaluate functions. It says which ordered pair could not be part of this function. And one of the things that I'll look at first is going to be all of my x values. I've got 5, I've got 6, -1, and -3. If you notice, answer choice D also has an x value of -1. That's going to be a repeat. Therefore, it can't be D because we can have no repeating x values in a function. Moving down to the second one, it tells me f of x equals 16x plus 2. They want me to evaluate that for x equals -2. So we're just going to be plugging in -2 where we see that x and simplifying. Same thing on the next one. This time it's f of x equals 10x over 3. Evaluate that for x of equals 6. That means plug in 6 where you see that x value and simplify. Now remember, we are going to be simplifying with our order of operations like we talked about in class the other day. Over here, the last few problems, they want me to come up with this equation in that f of x notation. So I'm just going to write that in on all of these because I know I'm going to have it in that form. For this first one, they're talking about a cell phone calling plan. The monthly fee is $5.10. The rate is 15 cents per minute. They want me to calculate the cost if I use 300 minutes. That means they want me to plug in 300 here. So I'm doing 300 times 0.15. I get 45 plus 5.10. So $50.10. Okay, next one, Friday night movie, $9.50 per ticket, and 1 large popcorn to share for $5.25. So I'm going to go 950x plus 5.25. Now, down below, if 4 friends go, that means plug in 4. So 950 times 4. Each ticket's 950, so I have to multiply that by 4. So I get 38 plus 5.25. That comes out to be $43.25. Okay, last little scenario, renting a jet ski, $45 per hour to rent one jet ski, plus a one-time fee of $8 for gas. So over here, my function is going to be 45x plus 8. How much would it be to rent it for 3 hours? That means plug in 3 where you see this x. So we get 135 plus 8, $143.